Okay, so we're looking today at plotting linear relationships. Okay, so that's a relation between two variables. Now, when we're given, when you're asked to draw a Cartesian plane and you're given a point and you're asked to plot a point, so here's my Cartesian plane. You'll have to get used to drawing these nice and quickly in your books. Oh, that's not minus 1, it's positive 1, 2, 3, minus 1. Okay, so I want to plot 1, 3 here. I go up 1, I go over 1, up 3. So there's 1, 3. When I'm, yes, Christopher, would be a good idea. So yes, so you can take notes today. Yep. So this is on plotting linear relationships. Okay, if I plot another point, so let's say my other point is 4, 0, and I'm asked to plot that. 4, 0. Okay. Joining these together, if I join them together, it's a line. No, if I join them together, that's a line. That's nothing extraordinary at the moment. But this links directly to algebra and algebraic formulas that we looked at in the last unit. If I were to draw a table, I'll come back to this in a second. If I was to draw a table, with values x and y. Okay. And my table is, okay, let's pick some 1, 2, 3, 4. Let's keep this formula we have to create nice and easy. Let's do 3, 5, 7, 9. Okay, so let's talk about creating a formula for this. So we had this in the last unit, so this shouldn't be too much of a stretch. If I add 2, that would be my rule. Okay, so adding 2 is my rule. Now, how do I create a formula from that? Y is equal to, add 2 means 2 times x in a formula. I think, does anyone have what would be the additional bit of information? So that's not going to give us to us. What would be the formula here?
2x plus 1.
2x plus 1. Okay, thank you. 2x plus 1. So that's a thank you, Jaden, as well. Okay, so that is a relationship between x and y. Isn't it? If I have an x value, it'll give me a y value. Now let's watch. Can I plot that? Well, yeah, of course I can, because I have x and y on the Cartesian plane, so I can show this line on a Cartesian plane. So I'll try and keep my scale. Oh, that's not a great scale, but that's okay. Okay, so let's plot my points. So when x is 1, y is 3. So we can plot this table now. This is a new thing. When x is 1, y is 3. When x is 2, y is 5. So I go to 2 and 5. When x is 3, y is 7. So I go over 3, 7. And what are these dots forming? Anyone write in the chat what the dots are forming? It's a line. Thank you for that. It's a line. It's a linear relationship. These have a linear relationship. I can join them together and form what's called a linear relationship. So, and I haven't even put them all in, but I can see the next point is going to make sense. Over when I have 4, I'm up to 9, and that makes sense up there, and so on and so forth. So when we create these algebraic formulas, what they really are linear relationships between a lot of x and y points. They all work. And that is essentially what we're doing today. What we're doing is using formula tables or formulas and creating linear relationships, or we're creating, diagrams based on those linear relationships. And now what we'll do more and more often then is skip kind of the table aspect of it and go straight between these two. But for today, we're going to keep the table involved. Does anyone think they could skip straight from here to there without doing a table? So for instance, for maybe our example at the start, anyone think they can create the formula for this line or the linear relationship? Anyone want to have a stab at it? Okay, there's no's going in, I know, yeah, but we haven't done it. Anyone want to think about it? No one wants to think about it. Well, this one, yeah, you could try now. I can help you try. If I create a table, it'd be helpful. If I have X and Y, I'm missing some points along the way. I'm missing 2 and 3. I only have 1 and 4 on my X-axis. So I'll do 1, 2, 3, 4, but I got to have 2 blanks. When I sub in 1, I get 3. When I sub in 4, I get 0. And I know there must be some constant jump between these. There's 3 constant jumps to get from 3 to 0. So I'm looking to create that formula. Harry thinks -1 is the jump. Does that work if that's -1, -1, -1? Let's see, that goes down to 2. That goes down to 1. Oh, I think it does work, yeah. So -1 is the jump. That means -1 is our multiplier, which means in our formula we have y is equal to -1 times x, or just minus x. And we need a plus or minus here, don't we? Anyone have a suggestion what I might add or subtract here to make this formula work?
+4.
Okay, thank you for a suggestion. +4. Well, let's test. Let's test. Let's do any point. Let's do the 3 here. So -1 times 3 is -3. -3 plus 4 is 1. All right, works for that one. Let's try 2, 2. -1 times 2 gives -2. Plus 4 gives 2. Hey, it does work. So here's my formula. Y is equal to, well, minus x plus 4. Awesome. So that means I can get any point along this line that I've drawn using this formula without having to go to that table. So when x is 0, what's y? So that'd be y take away 0, I suppose, plus 4. Y equals 0 plus 4. So it's here. Okay, Christopher. It's at 4, and that makes sense. Look, it's on the line. Yeah. And it's a linear relationship. Isn't it interesting that this crosses the line at 4, and here we have plus 4? My other example crosses the line at 1, and the adding thing is plus 1. That's interesting. Okay. We're not going to do much more than this new theory for today. But do realize a couple of things. The links between this algebra and this coordinate plane, or Cartesian plane, whichever you want to call it. We can plot points. When we join them, if they form a line, it's called linear. If they don't form a line, it's called non-linear. So dots that are random, perhaps we have a dot here, here, and here. That's not a line because I draw one straight line. I can't go through all three. I have to turn, don't I? Sometimes functions or lines, these things are called functions as well, relationships, turn. And they can go off. And of course, in real life, more than likely, one of these things will turn. Our formula is not always 2x, it's not always times by a nice number, or it's not always x, it could be x squared or cubed. But for now, we are only dealing with, is it linear, as in when you join all the points, is it a line? Or is it non-linear? When you join the points, it doesn't make a line. There's our two options for so far. So, let's just stop recording for a second.